Hi everybody, welcome back. In our last video, we went over this kind of theoretical example with Krusdar and Maria and looking at the effect of health insurance on health. And what we saw was that the problem is, in reality, we can only observe the final health outcomes. We don't observe everything. Remember, Krusdar was kind of more prone to being sick and benefited from having health insurance, which we actually see here. Krusdar with insurance, Krusdar without insurance, and he benefits. Maria, she's just as well off. She has 5 health with or without health insurance. So here in this unobservable line, we saw that kind of the difference between health outcomes for Krusdar and Maria if neither of them had insurance. And that's where we get this -2, and that is what we call the selection bias. She did not select into having health insurance because her health outcomes wouldn't have benefited. And so we saw that kind of on a two-person level, but as I mentioned at the end of the last video, this also carries over to groups, and what we see is that differences in group means can be equal or are equal to the average causal effect plus selection bias. Okay, and so then we can see the average causal effect of health insurance on health outcomes for a country, for example. And in groups, how do we know that the difference in means by insurance? Let's start with that. In groups, how do we know? Let's do it like this. How do we know that the differences in means by insurance status, let's say health insurance status, is contaminated by selection bias? So again, remember, as we wrote this, a person with health insurance, any individual I with insurance, person I with health insurance is denoted like this. Without health insurance, for person I, and if we're looking at this, we see y0 I is everything about person I related to health other than health insurance. So why I1 or y1I, the only information that gives us about a person is whether or not they have health insurance. So by definition, everything else except for the health insurance is captured in yi and y0I. And what we can see by that, well, it's actually not what we can see, it's what we can't see. There's all this other information captured inside of this variable that we don't observe. But to start thinking about, or to kind of show how that's actually true, we'll come back to the same table we saw before, table 1.1, where, remember, we saw that people with health insurance had better health outcomes than people without health insurance. But what else do we know about these people? We know their race, age, education, employment, family size, family income. And we see some very, very important differences here. So we see not only do the people with health insurance have better health, they also, some ones that stick out quite a bit are 3 more years of education, higher levels of employment, and quite a big one here is significantly higher family incomes. And so as we talked about here, and also with Kuzdar and Maria, these people aren't equal to each other. And so if we only compare the summary statistics, we're not going to capture the full picture. And so everything is not equal. Or as we say in economics speak, it is not ceteris paribus. Okay, just for a couple examples, the insured group is healthier for many possible reasons. For many possible reasons. So one, we see they're healthier for many possible reasons. One could be possibly the causal effect of health insurance on health. That is still an option, but by just looking at the summary statistics, we don't know if that's actually the case. But that is still a possibility. But they also tend to be more educated, so that might improve their health outcomes. Higher family incomes, etc. But there are a number of things there which could contribute to health other than health insurance. So therefore, we can't quite claim that causality of health insurance on health. And even if nobody was insured, we would still expect the insured group to have better health outcomes. Because of selection bias. And this is actually because of the way the health system is kind of constructed in the US. This is opposite of the Kuzdar and Maria example. Because in reality, it's actually relatively healthy people who opt for insurance. And opt is kind of questionable here because of the employer provided plans. A lot of times those aren't as those aren't really optional, but in reality it is the relatively healthier people who end up having health insurance, and that's coming from that selection bias. That happens because of cost, because of incomes, and because of kind of employment situations as well. Okay, so if the only source of selection bias, and this is kind of a big if, but if the only source of selection bias is a set of observable differences, then selection bias is relatively easy to fix. Okay, so for example, if the only source of selection bias in our health insurance example is education levels, and again, if the only, so it's not the only, but suppose it is. If the only source of selection bias is education levels, then we can focus on samples with the same schooling and examine differences between insured and uninsured. To uncover the causal effect. Okay, so it would be like up here, up above, if the only source of selection bias was the education, we could just take different subsets of the sample by education level. So we could have some with, high school degree, some with a bachelor's degree, etc. And then we do only need to look at the summary statistics, and that difference would be a causal effect of health insurance on health. But the fact that people with and without health insurance differ in many observable ways the fact that people with and without health insurance differ in many observable ways suggests they may differ in many unobservable. They may differ in many unobservable or hard to measure ways as well. Okay, and that's what makes really econometrics tricky. And so even if we control for all differing observable traits, for all differing observable traits, we can still have selection bias. We can still have selection bias. And thus, coming full circle, the principal goal and challenge of econometrics is, as we wrote at the very beginning, the elimination of the selection bias that arises from unobservable differences. Okay, and that kind of defines the problem of econometrics. It gives you a little bit of background on how this looks with health insurance. And what we're going to do next is finally use randomized controlled trials to show how they are kind of the gold standard through which we should measure and kind of compare all other results. They are really big, really expensive, and time-consuming and costly. So in practice, instead of doing these large randomized controlled trials, we take observable data that's already been collected, and or we collect data ourselves, and then we do kind of econometric techniques with regression and some specific regression designs so that we can ultimately take care of this principal challenge. Okay, so that's going to be it for now. In the next series of videos, we're going to go into a lot more detail on random assignment and how researchers actually have used random assignment to understand the causal effect of health insurance on health. And the results are actually quite surprising. So stay tuned for that in the next series of videos, and I'll talk to you then. Thanks.